All right, it's hot. It's Friday, but I actually got to write some code. There's probably hopefully not horrifically compressed text scrolling by, but I actually managed to get some code going, and I'm pretty excited about it. Let's see, how can I lift this up and show you what I've been working on without breaking things? Well, I'll show you a board that's not actually populated, but this is the little board that I'm working on right now. It's got space in the back for an RP 2350. Shout out to Solder Party, who have their stamps, which are excellent to use. On the front side, I've got a USB port, a level converter that I'm kind of using as a LED driver and buffer. Hopefully, let me beauty YouTuber this and see if this works. But the main thing, it's got an accelerometer on it. It's got an LSM 6D S3 on it. And that's actually what I've been playing with. Is I'm writing a very simple driver for it. I've kind of been manually looking at the datasheet and figuring out how little I can do to get streaming data going, and also figuring out generally how this chip works. So I've just been kind of staring at the datasheet and getting FIFO continuous mode going. And so generally what I'm doing is I'm getting it set up. So let me look through the main. I kind of wire everything up, get my embassy USB stuff going, and then I actually wait until we have a connection, so it doesn't start doing stuff and print stuff before it's connected. And then I'm just using this info format, so it's basically logging. And this is running the Ergot NUSB router example that I grafted in the thing to print log messages. So I'm actually doing the formatting on the embedded system itself, which is, whatever. It's fast enough. It's a delightfully fast little chip. I run through this a manual setup process that I have, which is basically I just went through all the status registers on the device and figured out what I think it needs to be. The big thing is that it's a wired up. Let's see, do I have KeyCAD open? I don't have KeyCAD open, so let me pull that. But basically, the accelerometer has an interrupt pin that I'm configuring here, so that whenever I hit some threshold in the FIFO, so okay, I set up the accelerometer in the gyro, so they're running at some data rate. And then I set the FIFO so that every time at some other data rate, it pulls the latest data from the accelerometer in the gyro, puts it in a FIFO. In the FIFO on the chip, there's room for actually up to 4,000 data points, or 4096 data points. And I set a threshold at... What do I set the threshold at? I set it at 64 words, or 128 bytes. And then what happens is when the FIFO hits that threshold, it raises, or actually it lowers an interrupt pin. So my code will wait for that interrupt pin, and then, it's supposed to fully drain the FIFO, but I realized what I'm actually doing is I wait for it to go low, and then I drain data until that data goes low, at which point I stop. But what I realized I'm actually doing is, once I knock it down below that threshold... Oh, hey, Anatol. Once I knock it down below that threshold, it stops draining. So this first... What I'm actually pulling on each of these is 4 FIFO status bytes and then 1 data word. So I don't know exactly what these are. I'm guessing it's probably X, Y, Z, and then gyro X, Y, Z. I'm going to have to figure out in the data sheet because I always get them in chunks of 6 at a time. So it's probably a safe bet that's what I'm doing. But this first is the number of remaining items, and my hex 20 means there's still 60, or I don't know how. It's telling me that there's still stuff. Really what I should do is wait for it to go low and then drain it until that first byte is 0. So let's actually do that real quick. So instead of just doing while this is low, what I can do is loop, get the regs, counter, and then if regs 0 equals 0, break. So let's just do this real quick. So then I can stop my code. I can reflash the Raspberry Pi. You can see we lose our USB connection, but it keeps going. This is me initializing it. And so now I get like 37 records at a time, and you can see it's kind of like more pulsy because I drain the entire FIFO whenever it's full. So I don't know why I'm getting 37 records, but I guess that's how many I have. But we can actually see this counting down. Then there's some bits here. Let's look at that second status register. That's going to be FIFO status 2. So watermark, or no, excuse me, it's 1, 2, 3, 4, FIFO empty. Okay, so actually really I shouldn't be counting down to 0. I should be counting FIFO empty. But no, that's awesome. That's what I want to see. And then there's some pattern. I don't, it says word of recursive pattern read at the next reading. I don't know what that means. But that's very nice of them to give me whatever that means. And then we'll have to figure out what this data is, because it just says like data low high. And I'm guessing it's gonna always be in some deterministic order. And I guess if I if I tilt my device a bunch, it appears to be different. And then if I set it back down, maybe it goes down to this, and then I tilt it on the other side, it does something. So it's definitely giving me data. I need to figure out what that data means. And this is probably just going to be like, take these values, and also I need to figure out what endianness I think I set it to little endian. So I can try and figure that out. But yeah, it is actually working. Right now I'm doing kind of the very silly, like I'm formatting everything. But one nice thing about working with this is that I can just leave my console running all the time. And even if I like unplug my device, yeah, my logs stop. But once I plug it back in, once it powers on, I'll see a little like connected, and then you can see that it's writing, and then it just resumes doing that because this is just always listening to any NUSB connection. So I'm pretty happy with this. Let me see. I'm going to try and hold this up, and hopefully I don't bust any wires. It would be blinking, but I don't have... Normally these blink, but I disabled the blink task while I'm doing this, whatever. But it's 8 channels. The idea is to use PWM there, because I'm kind of pretending to be a fake, like, quad-rotor drone, just because I'm not actually going to fly this, but to give context of like what you could do for a control loop for, because it's a fun controls problem of like, okay, if you're tilted like this, you know, you can see that you blink the LEDs at different rates and stuff like that. So it was a fun example of doing something like that. Yeah, but there's not too much extra on this, although there are some expansion headers. It just seemed like a fun little fake fake toy of a dev board to work on for a little bit. Yeah, that's kind of the bit, is that it looks drone shaped, but it's made out of like FR4 and stuff like that. So it's definitely drone shaped, but it definitely is not drone. I mean, I guess you could strap motors to it, but it's also got a USB cable and no battery. So it wouldn't be a very good drone, but it's definitely drone shaped, and it's meant to be more of like a tangible example project. I figured it was more fun than a rectangle. And the PCB is usually not the expensive part of the design. So it was funny to me, at least at 2 a.m. when I thought of the idea. But yeah, I'm pretty excited. It's just working. I'm not doing very message passy things right now. I'm definitely doing a lot of like print and format kind of stuff right now. So the next one would be like to make a less general version of this router and make some application that like listens to the incoming accelerometer, maybe dumps it to a file so you could graph it or something like that, or like, you know, vomit it out to some visualization tool. But then also like close the loop and do something vaguely control system-y, where you might want to like on the PC do the like, it's not sensor fusion, but do the whatever control algorithm you want to do to try and keep it level, so that you can see like if you tilt it one way, the arms on the side that are lower, you can see that they start blinking faster to try and, level it. And then when you've got it pretty level, you can see that they all kind of blink at the same rate and things like that. So I figured it'd be something more fun and tangible than, like I said, a rectangle. But it's cool to see it PID. Yeah, like a PID. I mean, you could do a lot of different control loops. You could do like a PID loop. That's probably what you would want to do, especially for something this simple. But yeah, the other thing that I want to see is like how fast can I get this data rate going as sort of like a throughput question. Right now I'm at like the slowest data rate, which is like 12 hertz. So that's why I'm only getting so many chunks per whatever. So yeah, it's a cool, fun little thing in my opinion. But yeah, I don't think I have too much more. I did get some stuff merged. Let me see. I don't have a browser over here. So I did merge support for the RP2350. So if anyone does want to play around with the RP2350, I've got the null and USB, and this tilt is actually the thing that I'm working on right now. So you can see I haven't pushed recently, but you can see vaguely what I have going on here. I think the pushed example is enough to like get the who am I register out of the accelerometer. So that's enough to check the wiring. But you don't have my board, so it's not particularly interesting for other people yet. But I'll probably, once this is more working than just like hello world, then I'll probably do another video on Monday or something of this working, and hopefully some fun graphs of like, okay, cool, I can get this level of throughput on here. I can do, 4,000 updates a second or something like that, and it's all sending messages and chunks with timestamps or something to that extent. So definitely have the first bit of it working. Eventually, like I said, I'm going to need to decode this value and make sure it's not just like spitting garbage into my reality. But the fact that these are staying fairly stable, and I bet if I tilt them a little bit, like some of them go negative and some of them go positive. So these are probably my least significant bits, and these are probably my most significant bits. So it looks like it's doing little endian correctly, which is awesome. And then I probably also can bump up my SPI speed, because right now it's probably just the default. No, I did bump it up to 8 megahertz. Okay, so I don't know how long this takes to actually process, but it's going. And then I need to figure out like how I figure out which payload is which payload. And then again, maybe cheat and do not read the whole thing, but I don't know. I just need to do some back of envelope calculations of how much SPI bandwidth I actually need here, and then how much USB bandwidth I'm actually going to use for all that. But it's a fun little development cycle. This would actually totally work if I didn't have a debugger. Like, I do have SWD pins attached to this right now, but the fact that I can auto connect and push things, it wouldn't be so good if I wrote a firmware that immediately crashed all the time, because I wouldn't be able to debug that. But it's better than not, I guess, because you also have the ability to multiplex together like structured data and unstructured log data. And I think eventually I'm gonna want to have a log and a deformat sync for Ergot, so that you can just use deformat Ergot or log Ergot, and it'll just drain all the messages to the stack for you automatically, and just YOLO, don't care what your libraries are using for debugging. But that's not there yet. But yeah, I'm pretty excited about this. I'm glad that I got to end the week with some code done and not just docs, although, writing the docs has been good. But yeah. So Anatol, I don't know if you have any questions in the chat. Hopefully people in the future will have questions in the chat, or let me go ahead and check the discussions just to make sure that no one has opened up a discussion. No, I don't think we have anything new. So a reminder, next week, I'm probably just going to do Monday, Wednesday, Friday for the streams. Probably still morning and afternoon. If I get excited on Thursdays or Tuesdays and have something to share, maybe I'll jump in. But, Anatol does have questions, actually. I got a little chuggy there, so hopefully the stream is not Garbo. What questions do you have, Anatol? Or is my connection totally lost, and am I not streaming anymore? So Anatol asks, regarding packet fundamentals, are you doing exclusively point-to-point and then routing on top of that, or is there also a broadcast primitive that gets sent to all nodes? There is a broadcast primitive. It is very primitive, but it does full flooding style stuff. So let me docs Ergot. So in the Ergot docs, in the book, I have... Oh, no, actually, it might not be in here. It might be in the stuff... No, it's not in here yet. Let me pull up the... I did write docs for that. I just haven't moved them somewhere easy to find yet. So in notes... whip... I know it's on the 12th. This is where I've started writing my, feature overview. And this talks about the things you can do now. So there is a totally flooding broadcast message. So when you send it out, it'll just get echoed out to every interface until it hits some TTL. It won't. It's smart enough that if you send it out here, it won't get sent back out here. So it won't loop over and over. But basically Ergot's version of topics in Postcard RPC are total broadcast things. Stream is a bit choppy. Oh no. Hopefully people are still here. So I tried switching, making sure... Ooh, let's not open Studio on here. Well, I don't know if this is all visible. If this ends up being terrible and choppy, I do have a recording, so I'll replace this, I guess. But hopefully this is visible, and I'll figure out what's up with my internet. But. So it has broadcast, and you can do point-to-point. The topology doesn't really matter, so you can use it over a point-to-point link like USB, or you can do it over a broadcast medium like that. The plan is to support either. On a broadcast medium, you'll be sharing the total available bandwidth, but on a point-to-point link, you'll have dedicated bandwidth. So yeah, you'll definitely be able to use it over RS-45, and my hope is that for things like broadcast, like flooding broadcast, it's smart enough to only send that packet once if we know that everyone can hear it on there. And then you'll still be able to do point-to-point stuff over endpoints or over a broadcast medium like this, because the other devices will just ignore messages that aren't for them. But to answer your question from a very high level, you should be able to... Ergot has both broadcast and point-to-point kind of operations, but you also can do them over broadcast or point-to-point mediums. So you can do either over either. Yeah. I don't know what was up with my internet. I think my laptop might have still been on Wi-Fi, even though I have an Ethernet cable plugged in. So we'll see if this is more reliable now that it's on wired Ethernet, and I should probably do that more often. But yeah, so hopefully that answered your question, Anatol. Anything else or anything? I mean, you and I can just go chat about. I'd love to get this going for you over RS-45, and if you want to borrow some of the hardware that I have, these little Ergot boards that I made. I think I have 10 of them total. I think 1 or 2 of them I might be using for projects around my house, but I'm happy to like sort of get them working and then hand them over to you if you want to play around with those, because these ones will also go up to like the full 8 or 10 megabit per second that the transceivers support. It's not limited to the 250 kilobit per second that the ones from that company Seed use. But yeah, if you want to do that, or if you want to borrow some of those from me, or if you want to collaborate on something, let me know, because it'd be dope to get this going. Yeah, I'll probably do it on a stream or something like that, getting the Ergot stuff ported over to be on top of Ergot. But yeah, if anyone else has stuff to share on Monday, it'd be cool to do a community show and tell at some point once people have stuff running. But until then, I'll keep sharing stuff. I hope everyone has a good weekend. I can't wait for it to not be so damn hot here in Europe. And I will see you all on Monday. And I'll go back and listen to this. And if it's super choppy and terrible, then I'm going to go back and delete this live stream and upload the video instead. But yeah. All right. Have a good weekend. Bye.